So now we're on with two problems that we're given for homework. I had assigned the even numbers to you all for homework, but I'm going to go ahead and show you how to solve the odd numbers. And like I said in class, I give you the homework, but my expectation is for you to do more than I assigned to you, just so that you can be better prepared for the test. So here's how it goes. At the beginning of a trip, the tank of Chloe's car was filled with 12 gallons of gas. I'm going to underline that. That's important. When she travels constantly on the highway, 60 miles per hour, she consumes 1 gallon of gas per 35 miles. So let's take note of that. 60 miles per hour, she consumes 35 miles. Okay? If she travels 5 hours and 15 minutes, so 5 hours 15 minutes on the highway at a constant speed of 60 miles per hour, how many gallons of gas are left in the tank? So she travels 60 miles per hour for 5 hours and 15 minutes. What I like to do is I like to convert to a fraction. For some of you that like decimals, you can do that as well. So for me here, this is 5 hours and 1/4 of an hour. So 5 1/4 hour multiplied by 60 is going to give us how many miles she has traveled. So this is, for those of you who like decimals, you can do 5.25 multiplied by 60. So here is going to give me 21/4 multiplied by 60. This is going to give me 21 multiplied by 15 is 315. So this is also the same here. It's going to give you 315. So the question here is trying to find out how many gallons of gas are left. So the question you need to ask yourself is how many gallons of gas were used for this trip. Remember, when she started with 12 gallons of gas, but when she travels at this rate, 60 miles per hour, she burns 1 gallon of gas every 35 miles. So what you need to figure out is how many gallons of gas does she burn to travel 315 miles. So all you have to do there is you divide this by 35. This is going to give you 9. So how many gallons of gas are left over? It's 12 minus 9. It's going to give you 3. So let me show you another approach that I think is worthwhile. So if she travels at 60 miles per hour and she burns 35 miles for 1 gallon, when she travels 35 miles, she burns 1 gallon of gas. So what I can actually do is find out how many miles she can travel with the amount of gas she has in the vehicle. And that will give you 35 multiplied by 12, which is going to give you 420 miles. So here now you can say, instead of doing it this way, you can also say because she traveled 315 miles and the maximum she could travel with that amount of gas is 420, then there are 420 minus 315 miles left on the amount of gas that she has in the car. So this is going to give us 105. And then to find out how many gallons that represents, you divide by 35, and that gives you 3. So just two different approaches. Once you practice the different approaches, you can find which one you prefer. For me, it doesn't make a difference, but I'm sure some students prefer one way or the other. So a rock climber is climbing up a 450 feet high cliff. By 9:30 a.m., the climber has reached 90 feet up the cliff, and by 11 a.m., he has reached 210 feet up the cliff. If he climbs with a constant speed, by what time will he reach the top of the cliff? Now, let's look at it. We're trying to get to 450 feet. That's going to be our maximum height, 450 feet. Now we at 9:30, so 9:30 we have 90 feet. At 11 a.m. we have 210 feet. Now we need to find out how long it's going to take to 450 feet at the same rate. So what we need to look at here is how much time has elapsed here and how much distance was covered. So here you can see that if you subtract 11 a.m. and 9:30 a.m., you're probably going to get 1 hour 30 minutes. So you have 1 hour 30 minutes and you have 120 feet right here. So now let's find out how many feet are left. What's the difference in this distance? You have 240 feet. So now we can see here that if you travel 120 feet in an hour 30 minutes, how long will it take you to travel 240 feet? I can just multiply by 2 here, multiply by 2 here. It's going to give me 3 hours. Okay, so what we're going to do now is we're going to add 3 hours to 11 o'clock. So 11 o'clock, and then we're going to add 3 hours to it. That's going to give us, we can say 1400 hours. You subtract 12 because the time is in PM. This time we have right here is going to give us the 24-hour clock. So we subtract 12 o'clock from that. We have 2 p.m. In 2005, a house was purchased for $280,000, and in 2013, it was sold for $334,000. What I like to do with every question is just to kind of write it out so I can see exactly what's happening. So 2005, I have 280,000, and then I have 2013, I have 334,000. Assuming that the value of the house increased at a constant annual rate, what will the price of the house be in the year 2018? Okay, so what's happening here is we have 8 years, and then here, if you subtract 334, you subtract 280 from 334, you are left with 54. So you have 54,000. So what we can see here, take note of this constant annual rate. So we go $54,000 increase in 8 years. We can do 2 things. One, we can find out how much it increases every year, which is, so we divide this by 8, divide this by 8. So for 1 year, our increase is going to be about, if you put this, let's do this. I don't really like calculators a lot, so I like to do this on my own. So this is going to be 6. But take note that this kind of problem, you may be allowed to use a calculator. I think this typically appears on that calculator portion. So you can use it, but I think it slows you down most times. So this is 48. So you have 6, you bring down a 0 here, 7, this is 56. You bring down, so you subtract, you have 4, you bring down another 0, you have 5, multiply by 8 is 40. So then you have the last 0. And that's it. So for every year, we have $6,750 increase in price. And now we're trying to find out for 2018. So take note, we need to remember that 2018 and 2015, that's going to be 5 years. So how much will that property increase from that period of time? We multiply this by 5. It's going to give us 0 here, 25, 2, this is 35, 37, 3, this is 33, 750. So what we're seeing here is that by 2018, you will see a $33,750 increase from 2013. So what you're going to now do is 334,000 plus 33,750. So you have 0,57763, 367,750. So that's the approach. It's the best way to go about it, honestly. I wouldn't show you another one. It will slow you down. To join East Lake Country Club, one must pay D dollars for a one-time membership fee and pay W dollars for a monthly fee. So one-time membership. So let's look at this. We're going to write something like this, really. And B is your one-time membership and M is your monthly fee. So let's go ahead. I'm going to start off with this. It's going to be WX plus D. That's what this is telling me right here. If the first month is free for the club, what is the total amount? So the first month is free. This is the number of months. So Y is equal to, this is the monthly fee. Okay. The first month is free. So we're going to subtract 1 from X because X is the number of months. And then we're going to add D to that. So let me kind of go through this again. When you have this, I always look at this as you're writing an equation using the Y equal to MX plus B method. So it's like your standard linear equation. So we have D dollars for a one-time membership. So that is something that doesn't change. So that's your, I call that your y-intercept. So if you had something like this, it's going to look like that, something along those lines. And you'll see this as, this is your y-intercept. So if you do not even use it for any period of time, you're going to pay this. On the first day of being a member of that club, you're going to still have to pay the one-time membership fee. So that's why you have D here. W is the rate per month. So that's your monthly fee. And the reason why we have X minus 1 is because the first month is free. That's all there is to it. The other way you could look at this also is Y equal to WX plus D. This is the month, this is the rate if nothing was free. But if the first month is free, we can subtract W from that. So look at it this way. Now we can group common terms together so we can factor out. So we have WX minus W plus D. So then we can say W X minus 1 plus D. So it gets you to about the same place. Number 5, from 1990 to 2000, the population of City A, so let's look at City A and City B. City A went from 12,000 to 28,000. City B went from 18,000 to 24,000. If the population of the two cities increased at a constant rate, in what year was the population of both cities the same? Okay. So let's look at, this is a 10-year period. So take note of that, 10-year period. So what happens here? We have a 16,000 person increase. This is 6,000. So now we need to find out the two cities increase at a constant rate. So now this means for every year it increased 1,600 per year. This one increased at 600 per year. So we want to find out at what time did they have the same population. So A is going to start at 12,000 and an increase of 1,600 and then the number of years. X will be the number of years after 1990 that they were the same population. Here we have 18,000 plus 600x. Remember I said x is the number of years after 1990 that the populations were the same. So now we have our equation. So I'm going to subtract 12,000 here, subtract 12,000 here, and I have 1600x equal to 6,000 plus 600x. Now we can subtract 600x here, subtract 600x. So we have 1000x equal to 6,000. Now we divide by 1000 to get the number of years. So therefore, we know that x equal to 6. So what this x value represents is the number of years after 1990 that both cities had the same population. So you add 1990 and 6. So you have 1996. So in the year 1996, both had the same population. You can go ahead and test it out if you want, but this is how you go about this type of problem. Finally, an empty 1200 gallon tank is filled with water at a rate of 6 gallons of water per minute. At the same time, so let's look at tank. I'm going to call this tank A, and I'll call the other one tank B. So this one is filling up at 6 gallons per minute, 6x. At the same time, another 1200 gallon tank that is full of water is being drained. So that's different, drained and filled. So you're starting at 0 plus 6x. Now here you're starting at 1200 because it's already full. And then you're draining, which means you're losing water. So that's going to be a subtraction at the rate of 9 gallons per minute. How many minutes will it take the amount of water in both tanks to be the same? So you have 6x equal to 1200 minus 9x. That's your equation. So 6x is for tank A to fill it up. 1200 minus 9x is a drain rate. So we add 9x to both sides. Add 9x to both sides. So 15x equal to 1200. We divide both sides by 15. And so your x is going to be 80.